So that's the assignment. This is your ID. So based on your last two figures, if the last figure is 4, then X is 4. And if the second last is 3, your Y is 3. So that means in this example, it depends on your ID. So that 20 plus X would be 24. And 20 plus Y would be 23. And then the height is 24. Okay, so this is the first thing we should do. We have to set the dimensions, and then all the results will depend on the dimensions. If you get this wrong, everything will be wrong. Okay, so we are going to analyze this building. So this building can be like well, it's a brick building with a lot of windows. So it can be one of the mills that we have in the city. And we want to refurbish this building and to create apartments. So this is a very successful business here in this area. Okay, so if you want to invest in this building, you buy the building as is, and then you have to refurbish. And the first thing we have to do is to improve the energy efficiency of the building. Okay, because now there are rules and regulations that were different than when the building was built. So what we find is this. We have to use the Excel spreadsheet that you are working with to calculate the R value and the U value of the following walls and roofs. Okay, so this is the wall that we find, and this is the roof that we find. So first we have to analyze this building, and then the second step will be to improve the quality of this building to quantify the energy savings that we can get. So if you open the assignment, or if you open the file, this is what we have to do first. We have to calculate the R value and the U value of the walls. Let's do it. And you have to sketch. Okay, so another requirement is that we need sketch details of walls and roofs with description of materials and dimensions. You can sketch it, and then you can take a picture and paste it here on the PowerPoint, or we can do it with the PowerPoint shapes. Okay, so the wall is 4 inches of brick, so we can use this shape, and we can have 4 inches of brick. Then the second layer is 2 inches of air cavity. Okay, so I'm going to insert another layer, 2 inches, and I'm going to use a different color. And the next one is 6 inches of fiberboard. So we have to create that rectangle with 6 inches of fiberboard. Try when you are dealing with or when you're working with the thermal insulation, try to make it yellow or orange, because if we see a list of materials, and when we see the yellow stuff, it's where the thermal insulation is. So this is common. Okay, so if you are designing a building or a building detail, try to make sure that this thermal insulation is something yellowish, something like that. So that's the 6-inch thermal insulation fiberboard, and then we have a 1/2 inch of gypsum board. So 1/2 inch. Here. And if there's a different material, we should have a different color. Okay, so this is it. Is this enough? No, because we need dimensions and materials. Okay, so I don't need to read this to understand that we have 4 inches. So you can insert text, and this is a 4-inch layer. This one, it's a 2-inch layer. This is 6-inch. And finally, here it's a 1/2 inch. Okay, so here we have all this information. And finally, we need information about the material itself. So we can insert another text, and this is brick. The second layer is the air cavity. The third is the fiber glass or fiberboard. And finally, we have the gypsum. There you go. Okay, so with this one, we have brick 4 inches, air cavity 2 inches, fiberboard 6 inches, and gypsum, the interior finish, 1/2 inch. So this is what I mean with the sketch details of walls, roofs with description of materials and dimensions. So what's next? We have to calculate the R value of this wall. We will calculate the R value and we will paste here the table. So I have to open the Excel file. And we just create the same detail here. Okay, so, well, I have already done it here. So this is brick. The thermal conductivity is 9. The thickness is 4. The air cavity, well, that's something new. So for the air cavity, here on this statement, we have the information about the air cavity, and we have the thermal resistance. Okay, so we don't have the thermal conductivity. If we had the thermal conductivity, or if we didn't have this information, we would use the table that we have here, because here we have air. Okay, so this is the first unit, this is the second unit, BTU hour, Fahrenheit feet, and we need these units, BTU inch, hour, Fahrenheit feet. So this is the unit that I would use for the air cavity, but that works. So this thermal conductivity for air works when we have a non-ventilated air cavity or chamber. Okay, for example, in glasses, here we have glass. We have 2 panes of glass, or 3 panes actually, and we have 2 air cavities here. But these air cavities are not ventilated, so they are not in contact with indoor or outdoor air. So if we have something that is not ventilated, we can use this element. If it's ventilated, usually when we have a brick wall, we want to ventilate this air cavity. Why do we want to ventilate it? Well, that's another story, but we do want to ventilate it. Okay, so when we have ventilated air cavities, that means that some air, indoor or outdoor air, can go through that air cavity. So the thermal resistance is not as much or as high as it is when we have a non-ventilated one. Okay, so for ventilated cavities, we need this number, we need the thermal resistance. So in this case, we don't use the thermal conductivity and the thickness. We just use the thermal resistance. Okay, so we type here 1.5, which is the thermal resistance. This cell doesn't have a formula. The rest of the cells, they do have formulas. It's always thickness divided by thermal conductivity. But with air cavities, if we have this information, we don't need the formula. We just type on this column where the R value is 1.5, and that's it. We don't need anything else. So then we have fiberboard, 6 inches. So the fiberboard is 6. and the thermal conductivity of fiberboard is around 0.3. And finally, we have a gypsum board, ½ inch, and the thermal conductivity is 1.17. Some of you are emailing me about where can I find the thermal conductivities of different materials. Well, remember that we did this. We have this table. So if you have this tab here on the same Excel file, we copied this from the engineering toolbox. Toolbox, thermal conductivity. Thermal conductivity. So here we have solids, liquids, and gases, thermal conductivities. And we just copied this table and pasted it. But remember that then we have to change units. Okay. If you activate the blue units, these are BTU, feet, hour, Fahrenheit, and we have to turn this into BTU, inch, hour, Fahrenheit. It's just multiplying this number, the blue text, times 12. Okay. So we can find, I think I have used this list of materials for brick. Let me see, in brick, well, here we have different brick values. We have brick, dense, insulating, fire, whatever. I have used 9. If I want to find out the values of other materials, I have to multiply always 12 times this. Okay. But anyway, brick insulating, you see that thermal conductivity is very low. Here we have the brick common, it's around 4, brick dense, it's around 9. Okay, so I selected 9, but I would have selected 4 because it doesn't matter. What really matters is the thermal insulation. Then the fiber board, I think I took this from. Okay, so here we have fiber insulating board, and this is 0.33. Okay, so I should, well, let's type 0.33, but it doesn't affect that much. So this is the table. So you only have to type the material, the thickness that we have in the drawing, and then the thermal conductivity that you can find in this table. Then we copy all this and we paste it here. So this is the first part of the assignment. We have the detail with the materials, the thickness, and here we have a table with the material, the thermal conductivity, the thickness, and the thermal resistance. And I have thermal resistance and the U value, the thermal transmittance here with the units. So everything's there. Okay, so that would be points number 1 and 2. This is it, the R value of walls and the U value of walls. Here, well, we have only one kind of wall. So this is it. Then you have to do the same with the roof. Okay, so now we have the U value of roofs and the R value of roofs, but in this case we have the average. So remember what we did on Monday. In the roof, we have these asphalt shingles, then we have another ventilated air cavity with the same thermal resistance. Then we have fiberglass and rafters. So when we have this bar here, means that we have either fiberglass or rafters. And here we have the air cavity, another air cavity with the same thermal resistance. And finally, the finish, it's the gypsum board. So you have to draw the detail. And here we're drawing walls. So a wall is like this, so layers are vertical. But if we are drawing a roof, and then the detail of the roof, we have horizontal lines. So let's do it. So the first layer is the gypsum board. And let's try to use, if we have used this color for the gypsum board, be consistent and use the same color for the same materials. Okay, so that was the gypsum board, ½ inch. Then there's an air cavity, 3 inches. So I select this. And what's the color for the air cavity? It's this light blue colors, the light blue color. So I select this one, the pink one. Those. Then what's next? Air cavity, fiberglass and rafters. Okay, so that's the, so we have fiberglass, which is the thermal insulation. So I can use fiberglass, it's 6 inches. And I use the yellowish, where's the yellowish thing? Okay. And now I have a rafter. So remember that the rafter is made of wood. So I need another material here. Okay. So this is the fiberglass, the thermal insulation. This is the rafter. And here we have the air chamber. This is the gypsum. And we have another ventilated air cavity, but this one is 2 inches. And then we have asphalt shingles with 1 inch. Okay, so let's copy this one because it's the same material, make it slightly thinner. And finally, I have the asphalt shingle, slightly thicker. And this is a new material, so I'm using this gray color. Okay, so I'm drawing roofs. So in roofs, we have horizontal layers. And in roofs, if we have this system between thermal insulation and rafters, this is the detail. So now I have to include the dimensions. So text. This is a 3 inch air cavity. This is 0.5, the first gypsum board. 0.5 inches. Now this is 6 inches, 6 inch. This one is 6 inches too, because we are talking now about the thickness. Okay, so the thickness of this material is 6 inches. There's another air cavity here, 2 inches. Text. And finally, there is the asphalt shingles, it's 1 inch. Okay. Names. Asphalt shingles. The second is air cavity. Here I have 2 materials, fiberglass and wood rafter. Rafter. And then we have another air cavity. And finally, gypsum. Okay, so this is all the information we need. but we can do something else that I think will help us understand, because we have these dimensions. This is the thickness, it's 5.5, 3, 6, 2, 1. But we need this distance too. We need the distance between the width of the fiberglass and the width of rafters. So I can insert a new text, and we have 14 inches. Okay, so this 14 inches is this dimension. This dimension, I'm going to make it bigger like this. And now put it away. Okay, so this is 14 inches, and the other one is 2. Here, and this is 2 inches. Okay, so be careful with this. We have the vertical dimension, 0.5, 3, 6, 2, 1. The horizontal dimension, 14. Okay, so that means that in this layer, we have 2 different materials in this layer. So in this layer, we have an air cavity. In this layer, we have a gypsum. Here we have the air cavity, we have the asphalt shingles. But in this layer, in that structural layer, we have wood rafters and fiberglass. So this is it. And now we have to use the Excel file to calculate again the same materials. So let's do it. If we have these 2 tables, this is what we did on Monday. Remember that we have an R value, and then we have the U value for the section with the thermal insulation. And then we have this for rafters. Okay, so I think if we use here the same colors, it will be easier to understand. So here we have fiberglass and wood rafter, and here we have the thermal insulation with fiberglass. It's that fiberglass. And the rafter here. What about the width? It's 14 and 2. So here we need 2 cells. The thermal insulation is 14. And here the rafter. Okay, so here we have 14 and 2 inches here. So let's do it. We have plywood. We don't have plywood here. We have gypsum. What's the thermal conductivity of gypsum? Let's find gypsum board. It's 1.17. So gypsum thermal conductivity 1.17. Thickness 0.5. Second, we don't have fiberglass here. The second material is the, okay, so I'm going to copy this here. Here. The second material is the air cavity. So the air cavity, again, we don't have thermal conductivity and thickness. We just have the R value of this air cavity is 1.5. So here we have to delete these two rows, and here we have 1.5. Okay. Then the next material is the fiberglass. So for the fiberglass, there are 6 inches, and then we need the thermal conductivity. So the thickness is 6. The thermal conductivity of fiberglass, let's try to find it here. Probably we don't have fiberglass. Yes, we do. Okay, so fiberglass is 0.27. Yes. So the fiberglass is 0.27. And the next is another air cavity. So this is the air cavity. And we don't have values here, and the R value is 1.5. There is no air gap. Okay, no, the next one is the asphalt shingle. So in this air gap, we can delete this row. Okay, and here we have the asphalt shingles. I think it's 1 inch. Okay, it's 1 inch, yes. And the thermal conductivity of asphalt, let's try to find asphalt. Find next. Okay, we have asphalt here. It's a 5.2. There you go. Okay, so that would be the U value, or the R value and the U value of this. Let's make this the format with 2 decimals. Looks better. So this is the R value, this column, and this is the U value. Then we need the same for the rafters. So what I'm gonna do is I'm going to copy all these, and then I will change just the rafters. Okay, and here, those are the rafters. It has to be red. And the rafters, what is the material? It's wood. So let's see what kind of wood we have here. Wood. And yeah, we have cellulose. Well, this is cellulose. Cellulose is another thermal insulation. So it's not exactly, let's try to find another wood. Okay, hardwood here. Hardwood is oak. Hardwood, it's something that we use for structures. We have hardwood and softwood. What's the difference? Well, hardwood is hard, softwood is soft. But we can use both for, I mean, hardwood, it's something that we use mostly for finishes. Okay, so if we have flooring, it has to be hardwood, because if we step on it too much, we end up. But well, we can use it for structures as well. What we are looking for here is about the thermal insulation. So the thermal conductivity of this hardwood is 1.1. So let's try to find other wood. Plywood, no, softwood. For example, pine. Okay, softwood is pine, and this is 0.8. So it doesn't make any difference. We can have 0.8 or we can have 1.1. Okay, so let's type here for the rafters. Let's type 1.1. Okay. So this is it. Now I think everything is correct because we have gypsum, air cavity, rafters, air cavity, and asphalt. And here we have gypsum, air cavity, fiberglass, air cavity, and asphalt. So this is it. This is the thermal conductivity through the thermal insulation, 0.04. And this is the thermal conductivity through the rafters, 0.1. Okay, so there's a difference. This is better because the lower the thermal insulation, the better, and the higher the thermal resistance, the better. But we are far from the goal of 40 to 50 R value. Okay, so this is 26. We might need more thermal insulation. When we refurbish that building, we need to add more thermal insulation because 26 it's not enough. But that's fine. Okay, and then remember that we were using the U average. So here we have the formula. But first, okay, there's something we can do here. Okay, so these are values of the section through the thermal insulation. Okay, so we can say that here the R value equals this, and the U value equals that. Okay, so this is the R value through the thermal insulation, and this is the U value through the thermal insulation. And now we have the R value and the U value through the rafters. This is the rafter and rafter. So these values are 9.9 and 0.1. 9.93 and 0.1. Okay. And then we will place here the two tables with the U average, but I think here we have all the information we need. We have the detail, we have dimensions, we have materials, and then we have the value through the thermal insulation, and then we have the value through the factor. The only thing that's left is the U average. But before calculating the U average, I'm going to calculate the area of walls. Okay, because if the goal is to calculate the thermal loads, so that's the final goal of all these exercises, we have to calculate the thermal loads, in this case through the wall. So I have the U value of the wall, but I have to calculate the area of the walls. In this building, we have 4 different elevations. We have south, east, west, and north. In the south and west elevation, we have windows, and here we have a door. In east and north elevations, we don't have any windows, it's just a wall. Okay. So what's the area of, so let's go step by step. What's the area?
Times width times height.
Sorry?
Length times width times height. Well, length times width times height.
Yes, so it's the area is always the width, the height, but we have different elevations here. So the first one is the north elevation. If this is the south, the north elevation, it's quite easy because in this case it's 24 times 34 per feet. What's the area of the south elevation. Well, the south elevation, we have 24 times 34, but we have to subtract the windows. So it will be 24 times 34. But we have to subtract the area of the windows. And what's the area of the windows? You see, you have this information here. On the south elevation, we have 9 units, 9 windows, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 6 times 4, so it's 24 each. So it's 9 windows times 6 times 4. Okay, so what's the total area of the south elevation? The area of the wall itself, of the rectangle, minus the area of the windows. So which is 24 times 34, okay, minus, and then I increase 9 times 24. 9 times. Is this correct? 672. Okay, so the area of the south elevation is 672 square feet. Now we have the area of east elevation. The east elevation is, okay, so this is west. So the east elevation is in one without window. So the width is 23. The height is 34. So 23 times 34. 700 feet square. And finally, we have the area of the west elevation. So the west is this one, it's 23 times 34 minus, and here we have 8 windows and 1 door. Okay, so it's 8 windows, 6 times 4, 8 windows times 24 minus 10 times 4. Because we have a door and it's 10 feet high and 4 feet. Yeah, 10 by 4. Yes, so it's 14 square feet. Okay, so we have all this rectangle, and then we have to subtract 8 windows, 1, 2, 3, 4, 5, 6, 7, 8, and 1 door. So this is 782 minus 14 minus 8 times 24. Yes.
Wouldn't the area of the south be 600 square? Oh, 600 square feet.
The area of what?
The south, wouldn't it be 600 square feet?
The area of the south.
Yeah, when you put 672, it's supposed to be 600. You put 6 times 44, it does not.
Let me do it again. 24 times 34. Yeah. 24 times 34. It's 816.
Yeah, minus 9.
And 16 minus it's 9 times 6 times 4 to 16. Yes, you're right. It's 600. Good. And so the area of the north is 816. Okay. The area of the south is 600. And are these correct? I think so. It's 23 times 34. It's 782. And we were doing this one, so it's 782 minus 40 minus 8 times 24. 8 times 2. Minus 8 times 2. So if I'm not wrong, this should be 542. 542 square feet. Okay, so those are the final values. This one, this one, this one, and that one. So now in the Excel file, we can insert 4 rows here, and we can have the area of the walls. So the area of the southern wall is 600. Okay, I did it last time, and this is 550. Are you sure? 8 times 24 plus 40. Minus 807.82. Okay, so I think this 550. I mean, this is not building science, it's just knowing how to add and subtract and multiply and divide. But anyway, the southern wall is 600. The eastern wall is 782, correct? The northern wall is 816, correct? And the western wall is 550. So what I have here, I have added up all this, okay, with the total area. I inserted the function, and then I drag these 4 values, and this is the sum of these 4 values, total 2,748 square feet. So this is it. Here we have everything I need to calculate. I'm going to delete this. So this is everything I need to calculate the thermal loads through the wall. I have the U value, I have the area, and remember that here I posted or I typed the location, indoor temperature and outdoor temperature. So we do have information about that in our assignment. We do. It's in Hartford. The indoor temperature is 72, the outdoor temperature is 20. So here I can type Hartford, 72 and 20.
Shouldn't 2 walls have the same area if they don't have windows?
All the walls the same area? Repeat the question.
Yeah, so wouldn't 2 walls have the same area because they don't have windows?
No, well, they have the same area. It depends on your numbers here. If you have the same
Alright.
numbers,
Yeah.
they will be the same area. But if you have the numbers, it's fine. Okay, so what's the thermal load? Remember that thermal load is always the same formula. We have U value, area, times indoor minus outdoor temperature. So if I type here equals the U value, this times area, total area, that one, times indoor minus outdoor temperature. So this is it. The thermal load is 6,640 units BTU hour. Okay. So I'm going to highlight this Okay, those are the thermal loads. I'm going to highlight this line, and I'm going to insert just a black line here because this is the first material. Okay, so every time I have a table with a material, I have this. Okay, and now it works, and that would be the thermal load through the walls. Okay, so point number five is the thermal load through the walls. Now I should do the thermal loads through the roofs, and then I can do the same through the windows and doors. Let's start with the windows and doors because it's easier, and then I will leave the most difficult part for at the end. So what about the windows and doors? Okay, so I don't have anything here for windows and doors. Well, we do have, but I want to do it again. Okay. So for the windows and doors, I'm going to copy this table here. And in windows and doors, we don't have to calculate. We just have to go to the catalog or the statement. And here we have the U value of the window is 0.8 and the U value of the door. Okay, so here we have the U value of the windows, 0.8, and the U value of the door, 0.5. Okay, and the other facades, they don't have any windows. So we have 9 windows here, 8 windows there, and we only have 1 door on the west elevation. Okay, so what do we need here? If these are the windows, actually, we don't need any materials. The only thing that I need from the window, it's the U value, it's the total U value. Okay, so I'm going to delete all these, and I don't need these layers. Okay, so the table for windows, it's quite easy because well, I just have the U value, so I don't need this. And I type the U value that I get from this, so it's 0.8. What I do have is area, because we have area windows. So we can copy the same table, because I can have windows in the north, the south, the east, the west. Okay, so I'm going to copy this here. And having the same structure, it's very important. Okay, so it's not about calculating things, about now how to do it, it's or the formula. We know that. But now we're working with Excel. So if we want to speed up things and we want to save time, it's very important that we always have the same structure. By the way, I have cut, but I wanted to copy. There you go. Okay, so it's very important that we have the same structure. So what's the structure? We have the same table here. We have 1, 2, 3, 4, 5 columns, and then on the 6th column, we have the thermal conductivity. Okay, that's fine. And here we have 1, 2, 3, 4 rows, because we have the area of the north, the east, the west, south. Okay, I need 4. And in the 5th row, I have the total area. So if I keep the same structure with windows and with everything that I do now, then if I copy and paste the table, I don't have to do anything else. I don't have to type formulas again. So that's why we're working with Excel, because if we want to type the same formula every time I calculate a window, a wall, a roof, it doesn't make sense. So I do this because I want to have a structure, and then by copying and pasting things, if I have to change the material, if I have to change the thickness, I'll do it. But the formula is the same. The formula of the U value is always the same. The formula for the thermal load is always the same. So that's what I'm going to try to do. We are going to copy all these. So for windows, we have the same structure. We have the area, now it's not wall, it's window. So we have the area of the south, east, north, and west. So what's the area of the southern windows? It's in the south, I have 9 windows times 24. Okay, so the area of the southern windows, it's 9 times 24. 216. What's the area of the eastern windows? I don't have any windows, so it's 0. But in another building, I would have windows in the east, okay? But in this specific building, it's 0. The northern, we don't have any windows, so it's 0. And finally, the western windows, there are only 8 windows times 64 times 6 times 24. 8 times 24. So this is 192. 192. Okay. And I don't have to change this cell because it's the total area. I have copied this, so I don't have to touch this cell. We don't have to change the formula. Okay, and now if I, and that's important, if I keep the same structure, okay, because if you double click here where the thermal load is, there is something wrong because the thermal load should be G14. The thermal load is the U value times the area times indoor minus outdoor temperature. That's correct. Okay. So now if I double click here, these are the cells that are included in the formula. The U value, the area, and indoor minus outdoor temperature. So that means I copy this row, the row number 20. When I copy this row downwards in another table, if I make sure that the position of this row is the same as in this table, so it's just below the total area. So this formula will take this value and this value. So that's what I'm going to do now. I have to copy this. The row number 20, Control C, sorry. And I'm going to copy it just below this. And it is 0. Interesting. Why? If I double click here, that's correct. I have taken this value and I have taken this value. This is the thermal conductivity and the total area, because I have the thermal conductivity in the same column and the total area 1, 2, 3, 4 rows below the thermal conductivity. But the problem is with the indoor and outdoor temperature, because we have taken those two and they are empty. So that's why it's 0. How can I fix this? Because if I take this value, okay, so if I copy this and paste it, they take 2 cells that are the same distance. Okay, so I can fix this if I type $, on these cells that I want to, because those cells, they don't change. I don't have to type indoor and outdoor temperature for walls, for windows, or roofs. It's always the same. It's always the same indoor temperature, and it's always the same outdoor temperature in the same building. So I'm going to type here $C, $2, and then $D, $2. Okay, so this doesn't change. Okay, so I still, if I click here, I still have thermal conductivity, area, indoor temperature minus outdoor temperature. But now if I copy this cell, that works. Okay, because this cell now, I'm taking the thermal conductivity, I'm taking the total area, and if I move it up, I'm taking the right cells for the indoor and outdoor temperature. Okay, so that's the magic of typing $, but you have to type $, twice, before the letter and before the number. So if you type $, that means that cell is always fixed. Okay, so you are always taking that cell. If you don't type $, that means that this cell is not fixed. It depends on the distance. If you have the U value in the area always at the same distance, that's fine. But if you want to get something that is fixed, it's always in the same place in this Excel file, then you have to type $. Okay. So if I imagine that now I copy all these because I want to create the doors. Okay, so I copy this. These are the doors. The U value of the door is 0.5. And we have only a door on this is the west elevation. So the rest of the doors are 0. I can have more than one door in one building. In this case, I have only one. And the area is 40 square feet. Okay, so if I go here on the west elevation, I have a door and the area is 40 square feet and the rest of the areas are 0. I don't have to do anything else because if I type this, I have the U value of the door, the area of the door, and I still have these two values because I typed $, here. Okay, and if I want to keep the same format, I can do this, and I can do this. Okay, so every time I have a black stripe, that means that I start a new material and I have a new thermal load for that element. Well, material, it's a construction element. It can be a wall, or a roof, or whatever. And here you have windows and doors. I think I will do this. Okay. Here we have windows, doors, and we have walls, and we only need to finish the roofs. Okay, for the roof, remember that I had to do this U average. I'm going to do it again. Okay, this is the U value through the thermal insulation, the U value through the rafters. But now it's very important that I keep, if I want to copy and paste this and make sure that at the end I have the total thermal loads here. So the thermal load, this number should be always in this column. So that's why I highlighted this green column, because the thermal load has to be here on this column. Okay. So these thermal loads in this column should be here. I have here two U values, this one and that one, but the value that I'm going to use is the U average. So where are the rest of the U average values? They are here, they are on this column. So I'm going to highlight this column because all the U values should be here. Okay, so you see that all the U values are here. So what, now I have to calculate the U average. But instead of placing the U average anywhere, I'm going to place it on this column. And then I will place 1, 2, 3, 4 rows, and on the fifth, we will have the thermal load. Okay, so remember that the U average, we have to, now we are speaking a language, and we are speaking to Excel. Okay, so Excel doesn't speak English or Spanish or Japanese or whatever, it speaks Excel. And what's the language of Excel? So we're going to type a formula, and we're going to calculate this U average. We have to do the first bracket, the second bracket, U value to the thermal insulation times area, or yeah, let's say area, the thermal insulation. Close plus, I open another one, U value of the rafter times area of the rafter. I have another bracket here because I opened the first one, I have to close it. And now I have to divide. I have to open another one, and this thermal insulation and close it again. Okay, so this is Excel language. And we can't type other symbols or a different order. If we don't type the correct order and the correct symbols, Excel doesn't understand what we want. Okay, so yeah, we have to learn Excel. It's quite easy because it's a machine. It's not the. But anyway, let's type this, and then I have to open two brackets, and now it's this value, the U value of this part of the roof, times the distance 14. I close this, plus open another one, the U value of the rafter, this one, times the width of the rafter, which is 2. I have to close this twice, and then I have to divide and open this plus that. There you go. And now if everything goes well, this value should be between this one and that one. This is 0.04, this is 0.1, and this is 0.045. Okay, so it makes sense. So this is the U average. Now, if I want to keep the same structure, I have one here in flat roofs. We don't have north, south, east, and west. I could have north, south, east, and west. Imagine that I had a building with 4 different orientations, and I don't have a flat roof. I can have a roof that is something like that. Okay, so we can have a roof facing south, another part facing east, another part facing west. So I could have different parts of the roof facing different affiliated roofs, again, north, south, east, and west. In this case, we have a flat roof, so it doesn't matter. But what I want is to keep the same structure. So I'm going to paste this here, and probably I don't need this. I just need the total area of the roof. Okay, but I want to make sure that I have 1, 2, 3, 4 columns, and then the total area. And what's the total area of the roof? 24 times 23. So 24 times 23, it's 552. It's square. What's next? The thermal load. So I can copy any row with a thermal load on it, Control C. I have to paste it here, just below the total area of the roof. And if I double click here, I am selecting the U average, the total area, and if I move it up, since I typed the dollars here in the formula, I'm going to select these two values. Okay, so now everything makes sense. Everything within these two black strips, I have everything I need. So I have materials, the R value, the U value, the areas, the total area, and the thermal load. I have another thing here. This is different because if I'm working with roofs, yeah, the roof, it has more rows because we have to calculate the U average, and I have to provide this information, the distance of the thermal, or the width of the thermal insulation, and the width of the rafters. But the thermal loads is the same, because for this, I need only just this value and this value. What we have above it doesn't matter, because I have typed dollars, because I want to take indoor minus outdoor temperature. And then if I have only a window, for windows, I don't need all these materials, thermal insulation, whatever. It just need to take the U value of the window. But I have areas. The total area and the thermal load is this and this, and the temperature for doors is the same. And what do I want to do this? Why do I want to have all these thermal loads on the same column? Because eventually I will need the total thermal load in my building. So when I'm done with, I have imagine that I have 5 different walls, 3 different roofs, 14 different windows, whatever. Okay, so I copy cells, I change materials, and I always calculate the thermal load. So at the end, I need to calculate the total thermal load of the building. So I only have to insert the function, the sum, and I go up. If everything is on the same column, here we have the total thermal load. And this total thermal load includes everything here. Okay, so it doesn't matter, colors don't matter. And if I don't have anything, that means that it's 0. If I want to insert another layers with doors, I can do it. And now this value includes the new layer. If I want to insert another kind of wall, I just copy this cell. I insert copied cells, and I have another wall here, and this value includes the new wall. Okay, so basically now if it works, and if it works with the first wall, the first roof, and the first window and door, now, okay, what do I need? Another wall, I copy the wall. What do I need? Another roof, I copy the roof. What do I need? More windows, I copy the tables with windows, and I don't have to change anything else. This is always including the thermal loads. If I click here, it's going to be always the thermal conductivity, the thermal transmittance times the area times indoor minus outdoor temperature.